Right, good morning. So what we've got today for lesson 8, starter. So if you can have a quick look at your exam question. And then I'd like you to pause the video and have a go at it. 5 marks. Find the first 3 terms in the expansion. 9 minus 16x, all raised to the power of 3/2 in ascending powers of x, and state the set of values for which this expansion is valid. 5 marks. And I've given you the correct binomial formula to use. So pause the video, have a go at it. Off you go. Okay, right. On this slide is my handwritten solution. And on the next slide is the mark scheme, so you can see how the marks were allocated. So I know it's a little bit of a dark screen there, so you can see I've taken out a factor of 9 to the power of 3/2, and then I've expanded. So if you have a little look at what's going on there. So I've ended up with 27 minus 72x plus 32x squared, and I've got the condition of validity on the bottom. The mark scheme looks like this. So you get, it's for the structure, so you get a mark for getting these 2 terms. First of all, that's inside that bracket, the binomial bracket. They're giving you more credit, so 2 marks for getting the second term, a method mark for having it written down correctly, and then a mark for it correct. And then your 4th mark is for the correct binomial expansion. It's a 5-mark question, so the final mark was given for the correct version of the condition of validity. You could see you could have that one or that one, but you couldn't have left it as the modulus of 16/9. X being less than 1. It has to be rearranged to a single x. Right, today's lesson. So what we're going to do is we're going to look at some harder questions that have a bit of an algebra twist with the binomial. So first question, given that the binomial expansion of 1 plus kx all to the power n is this, find the values of n and k. State the set of values of x for which this expansion is valid. So you can see that they're rewarding this with more marks because it's more difficult than the previous exam question that we've just done. Now, it hasn't told you anything about the power of n, but you can't use the year 12 version of the binomial formula, binomial expansion, because you don't know n. You know that this one works for all n, so you can't assume that n is a positive whole number and use that nice easy one that we were using in year 12. Also, you can see that it is suggesting that this goes on forever, and for this question you are to assume that it does. So you will use this version of the binomial expansion. So first thing I'm going to do is I am going to use my formula. I am going to expand 1 plus kx all to the power n using that formula. So I substitute it in. It's just a little bit of an algebra twist here. That's what's making this question more difficult. And I'm going to equate that to my expansion that I've been given in the question. So I'm now going to try and simplify this left-hand side a little bit more. Now, if I'm now going to look at the coefficient of x on both sides, so nk must be equal to -6. So you've obviously got 2 unknowns there. The only way you're going to be able to solve equations with 2 unknowns is you're going to need 2 of them. It's going to be some form of simultaneous equations. So I'm now going to compare my coefficient of x squared. So I need to sort this out a bit. So what I've done is I've obviously squared the whole of kx, giving me k squared x squared. So my coefficient of x squared on the left will be n bracket n minus 1 times k squared all over 2, and that's going to equal 30, because that's the coefficient on the right. So these are my 2 simultaneous equations, 2 equations and 2 unknowns. It's just they're not particularly nice, and you can't just bung them in your calculator. They're not in that form that you know. So the first thing I've done, and there are different ways for you to be able to do this, but this is how I've done it. I've taken the first equation and made k the subject. So I've got k is negative 6 over n. Because that's k squared, I then squared this. So I've squared negative 6 and I've squared n. So I'm getting k squared is 36 over n. And then I've substituted it into here. So I'm ending up with something that looks like this. I'm now simplifying it. And there are things that I could have done. I could have had a go at simplifying that a bit earlier, but I didn't. I've cancelled both those n's and I've cancelled that n with one of those and I've divided 36 by 2. So I've ended up with n minus 1 over n times 18 equals 30. I multiply both sides by n. And when I multiply both sides by n, I'm ending up with 18 bracket n minus 1 equals 30n. Multiply out that bracket. Take 18n off both sides, end up with n is 1.5. Sorry, I end up with n is minus 1.5. Put that back in to find k, and I end up with k is 4. Go back to the thing that you expanded binomially. Now you know that k is 4, so your thing that you're going to have to look at for your condition of validity is this kx, which we now know is 4x. So you need the modulus of 4x to be less than 1. So your expansion is valid. And you can see I've copied that from the mark scheme, that last bit. So your expansion is valid for the modulus of x being less than a quarter. Example 2. So again, another exam question. So this is a different style of question. So part I, expand that binomially, and that's going to give you 3 marks. Now that's quite a straightforward one, and that's why they're only going to give you 3 marks for it. So what you would do there is you would get your binomial expansion, it's ready to go, and you're only going to have to do the first 3 terms. So I'm not going to go into that. We will have done this expansion. We've done that in, I think, lesson 6 probably. It might even be in lesson 5 where we've been expanding things like that. Sorry, lesson 6 on Monday. Right, there's your answer. So I've gone into very little detail about that. It hasn't asked for the condition of validity, so all good. It's part 2 that makes this a more interesting question. So hence, what that means is using what you've just done in part 1. Expand 1 minus 2y plus 4y squared all to the power half. Now, you've done an expansion of 1 minus a single thing all to the power half. So what they want you to do is get that expansion and they want you to replace the x with something. So you can see, there's my expansion. I haven't done anything so far, have I? I've just rewritten it like that. And what I'm going to do is I'm going to have to think what I replace that with. And that half looks like it could do with tucking in a bit, right? So because it's 1 minus, I have to write it as 1 minus. So be careful. I've taken out a factor of minus 1. So that means when I take out a factor of minus 1 and put this in a bracket, I'm going to get minus, open bracket, 2y, and of course that's plus 4y squared, so that will need to be minus 4y squared. So that when if you were to expand that bracket, you would still get this. So what you're now doing is you've replaced that x term with 2y minus 4y squared. So you replace these x terms with 2y minus 4y squared, like I've done there. Now let's look at the question. So it wants you only to go as far as y squared. So the minute I'm going to start getting things that are like y cubed or y to the 4, which I might get when I expand this bracket, then I'm not going to bother with them, okay? The question is not interested in them at all. So all I'm going to do is multiply out those brackets. So I'll multiply it by the half. I've squared this, but I know that if I go any further with expanding this bracket to the power 2, I'm going to start getting cubes and y to the 4s. The question is not interested. It has said only as far as y squared. Had it wanted more, it would be giving you more marks than your 3 marks that you're getting. And then all you do is you sort that out algebraically. So there is your answer. Okay, pause the video. Could you do this exam question? It's got 1 more mark in part I than your previous one. So they're saying that they think this is slightly more difficult. And I think the reason it's slightly more difficult is because of the 3 there. We've got a 3 there, and also your power is negative. So if you could pause the video, do this question. Okay, you'd be expecting to maybe spend about 10 minutes on it, maybe just slightly less if you're in an exam. Okay, here's the mark scheme. So that's your answer to part I. Obviously, you need to do a reasonable amount of work there to get that. And then here's your solution to part 2. So you can see I've replaced with x plus x cubed, and they were only interested in the x cubed term. So quite a lot going on. That's a hard question, so well done. So your answer is 17/3. Right, other things that we like to do with binomial expansion is estimate values. Obviously you've got a calculator, you could just work out the value. So if you look at this question, they're wanting you to approximate square root of 9.4 to 3 decimal places. Well, of course, you could just put that in your calculator. But, you know, obviously that is not the point. They're wanting you to use a skill here where you use the binomial expansion. Now, we're going to do 2 questions like this. One, which is reasonably straightforward, and the other, which is a bit more challenging. So, first question. Use the first terms of this binomial expansion to approximate square root of 9.4 to 3 decimal places. So straight away, we're going to launch into expanding this binomially, and you know what you're doing. You obviously don't like that 9 there. Take it out to the power of a half. It leaves you this. Again, you don't need me to now explain what I'm doing here. You've done plenty of these now. So what you would now do, it only wants you to do the first 2 terms. So that really does reduce the difficulty of the question. So what I've done here is I've simplified it. I've then sorted out the condition of validity. Okay, that's not acceptable. So it's the modulus of x is less than 9/4, which I've written like that. So I know that this expansion will only work for values of x lying between 2¼ and -2¼ and that's important. I'm going to need that. Right, now to the question. They want you to approximate the square root of 9.4. So have a look here. You have to add 0.4 to 9 to get 9.4. Now that would work if your x value was 0.1. If your x value was 0.1, you will get 9 plus 0.4, which is 9.4. And 0.1 is fine. 0.1 lies in this range, so you can use it. If it didn't lie in that range, you would not be able to use it. So what you've done is if you replace x with 0.1 here, you will get 9.4, and then you simply replace this x with 0.1. So you get 3 plus 2 times 0.1 all over 3, which is approximately to 3 decimal places, 3.066. So that's what we would consider a straightforward one. A harder version of this type of question would be where it wasn't obvious what you would make the expansion or what you would substitute in for your value of x. And the reason being is that your condition of validity might not allow the most obvious example. So this, we would say, was a much harder question. Starts off okay though. Find the binomial expansion of 1 plus x, all square rooted, so 1 plus x to the half, up to and including the x cubed term. Okay, now that bit's fine. So again, I'm not going to go into loads of detail. Obviously, you would rewrite it like that. You would expand it binomially. It's all good. That's a 1. There's me putting it in my formula. That's it sorted. And you can see the condition of validity. Now that means x lies between 1 and -1. So there we are. It then says, use your expansion to get an approximate value of the square root of 5. So you think, that's just great, that's easy. All I need to do is replace this x with a 4 and I'll get 1 plus 4 to the power of a half, so the square root of 1 plus 4, the square root of 5. However, you are totally prevented from doing that because this expansion is not valid for any x values that are greater than or even equal to 1. You can only put in values that are between 1 and -1. So you cannot do that. You cannot put 4 in. So, you know, this is why this would be a much harder question because it requires quite a lot of thought. So what you've got to do is you've got to think, well, what values can you put in and then manipulate to get you what you want? And it's where we use our idea of surds. Now, I know that the square root of 5 over 4 is the same, using the law of surds, as the square root of 5 over the square root of 4, which is root 5 over 2. So what I'm going to do is, and I can see that if I managed to write this bracket here as 5 over 4, so the whole thing would be the square root of 5 over 4, I would then be able to split up this left-hand side where I would be able to isolate the square root of 5. So that's what I'm going to do. I'm going to use, it's a hard question. So what I'm going to do is I'm going to substitute x equals a quarter into here. The reason I'm going to do that is because 1 plus a quarter is 5 over 4. And a quarter lies in my range for x. So I'm going to substitute in x equals a quarter. So I will get the square root of 1 plus a quarter, that's that left-hand side. I can then substitute it into my binomial expansion. So I end up with the square root of 5 quarters is approximately equal to this here. Using my law of surds, which I showed you at the beginning of this question, this will split up to root 5 over root 4, which of course is root 5 over 2. I've put that into my calculator to get this fraction. And then all I do is I multiply both sides by 2. And there's my value. So a much harder question. So that would be hard. Okay. So here are the questions you're going to do. So question 1, and they are harder, so do take your time. Question 1, part B, I've given you a bit of a hint there. So that's similar to some of the examples we've done here. Question 2, again, quite a hard question. Question 3. 4, and then when you've done those, here are your answers. Thank you.